Nothing like starting with a cough. Okay. This is where we left off yesterday. I'm just going to go backwards a couple slides here and revisit. These transformations were very familiar, I think. Okay. When it's outside on the entire function, it shifts up or down just like it seems. And then we talked about when it's inside on the parenthesis, if it said x minus 2, then it would slide to the right. If it said x plus 2, it would slide to the left. Anything in the parenthesis is the opposite of what it seems. Does that sound familiar? Then we started talking about reflections. And when you put the negative around the entire function, then it flipped the graph over the x-axis, okay? When you put the negative inside, it would take a graph and flip it across the y-axis, okay? Questions on those? We were good? And that's explained here on your reference sheet. Okay. Now, this was an example, and I really need to stress that order matters, and it will matter on the quiz. There's a question just like this where you have to explain what 3 transformations were performed on the parent function, and you have to tell me in the right order. I think about it as an order of operation question. If I were to put a 10 in here, I would subtract the 1 and square root it. Then I would take the opposite out here, and then I would add the 2. That's the order that you're expected to explain it in, okay? So what does the minus 1 do? The inside one here, the subtraction, I should have, yeah, there's, okay, I did not ask the question well. The subtraction inside is a shift, which way? Right 1, okay? It is a horizontal shift, but if you just said shift right 1, I would take that, okay? The next thing would be do the opposite out here, and that was the reflection over which axis? Yep, over the x-axis, so upside down, okay? And then the plus 2 on the back, because remember, order of operation would say take care of all that, and then the last thing you do is the plus 2, and that is the vertical shift up 2. Students tend to do this, okay? They say, I would go right 1 and up 2, and then reflect over the x-axis, okay? Which is actually what this one would mean to do, because you would do inside, and then because of the parentheses, the last thing you would do would be the reflect. But I need you to see that here is the x-axis and here is the x-axis. Do you see that where that blue thing is are very different? Okay? Because when you reflect over the x-axis, you don't just flip it upside down. Okay, if we went up here and then totally reflected it, it would wind up down here. Just keep in mind order of operations when you're doing the order that you follow these in. Okay, really not a fan of this example, but we're going to talk about dilations now. We don't usually use the word dilations. We use that word in geometry. It meant to stretch or shrink something. Remember those? Okay, well, we're going to talk about vertical stretching and shrinking, or Ms. Abruzzo has used the word compressing. Okay, vertical stretching or compressing. That means it's going to go towards the x-axis. Okay, it's like someone sat on it or stretched it towards or away from the x-axis. So if you have a picture like this, and you're doing something vertical to it, it's going to go through the same intercepts and either be shrunk or stretched, but it crosses at all the same places. Does that make sense? Okay. And that is, if you have a 2f of x, which one would that be, the red or the blue? If the black was the original, I didn't do a very accurate job, but which one is a stretch? 2 would be a stretch, so that would be like the blue one, okay? And a 1/2 f of x would be like the red one, I shrunk it. Okay, obviously I didn't use half when I shrunk it, but something, okay? This on a horizontal dilation, the stretch or shrink is in towards the y-axis or away from the y-axis, okay? So it is compressing in this way or stretching out this way. It changes x-intercepts. So if you had a graph, like I drew a second ago, like this, okay? And it was f of 2x. Now, when it's inside, what happened when it was inside the parenthesis back here, guys? When it said -2, it was actually to the right 2, yes? Okay. Well, same with this 2. When I put the 2 inside here, it is actually a horizontal compression. Now, I'm not going to be super picky. I would say by 1/2, but you can say it compresses it by a factor of 2 because it's getting twice as shrunk in. So what would happen, it would still go to those same maxes and mins, but it would shrink in this way. Do you see what I'm talking about? That's with a factor of 2. It's compressed, not stretched. If it was f of 1/2 x, that's a horizontal stretch by a factor of the reciprocal, which this was half as much as well. This is 2 times as much. So that one, let me find my cursor again, would start here and it wouldn't cross until here, but it would have the same y values. Mine doesn't look very accurate. Okay? It's horizontally stretching when it has a factor of 1/2. All right, so help me. If this is the parent function, okay, let me go over this one real quick. So this is the parent. I'll call him P of X. Can anybody tell me what this red one would be? Vertical or horizontal, stretch or shrink? It's not very accurate, but from that black one right there to this red one over here. Yes, it is a vertical stretch. So that would be on the outside with an A value greater than 1. Okay, I'm just going to make it 2. P of X, Hofbauer. What is the blue one? Did the x-intercepts change? I'm talking about this blue one. Are you talking about the same blue one I am? Sorry. I'm talking about this blue one. The x-intercepts didn't change. So what is it called then? That would be a vertical shrink because it didn't change x-intercepts. It just changed the y values. So that would be like f of, I don't know, it looks a lot shrunk to me. Well, if we're going from the original one to this one, it's not as much, but it's a shrink vertically maybe by 1/3 or something. No, it's out here, Hofbauer. Way to confuse everybody. All right, now let's go over here and talk about this one. If this is the parent again, what happened to this red one from up here down here? See, this is -2, and this is positive 3. But now negative 2 is over here, and positive 3 is over here. So what happened? It smushed in, yes? This one was shrunk in this way. So that is a horizontal compression. But when it's horizontal, it's the opposite of what it seems. So instead of putting a 1/2 in here, what goes in here would be like a 2. The blue one, from the black one up here to the blue one down here, it's stretched way out this way and this way. That's a horizontal stretch. And a number that would make you stretch something horizontally would be like less, a 1/2 or a 1/3 or a 1/4 or something in here. Okay, outside of the parenthesis, it's what it seems. Whole number, stretch, small number, shrink. Inside the parenthesis, it's opposite of what it seems. Do you get it, guys? Yeah. 3 compresses it, makes it smaller. A 1/3 inside stretches it or makes it longer, further out. All right, dilations can be very misleading. That's why I don't like this example, because to me, this green one that they're talking about is a vertical stretch, looks exactly like this green one over here that's a horizontal compression. Okay, parabolas are very hard to tell. All right, we're writing this in our notes quickly. Expanded vertically if A is greater than 1. So this is what I did last hour. I don't know if this is a good plan or not, but this was our original parent function, and it went through 1, 1 and 4, 2. So it was a square root function. Expanded vertically would be like 2f of x, and it would go up. So it would go through 1, 2. The y values are changing, guys. And this point over here would be at 4. It would be up twice as far at 4. If it were compressed vertically, like 1/2 f of x from that parent function over there, it would be doing this. At 1, it would only be at 1/2. And over here at 4, instead of being at 2, it would be at 1. It's changing y values. Do you want me to try to do the same graph? What is the difference if it's compressed horizontally? So if you had f of 2x, whoops, inside of here, it is compressed by a factor of 1/2 horizontally. So instead of going through 1, 1, it would go through 1/2, 1. It's not really a good example. Let's do this as our parent function, okay? Let's say we had something that was crossing at -2 and +2 out here, so it was doing this shape. If it's compressed f of 2x, it is compressed horizontally. It will do the same shape, but it will do it crossing at -1 and +1. If it is expanded horizontally, like f of 1/3 x, okay, it's going to go all the way out here to -6 and +6. It is changing x values for both of those. the y value, where it peaked up here, the y value would stay the same. Better? Maybe? Everybody good? All right, this is off your reference sheet. If you're thinking you're going to use your reference sheet for homework, I need to help you fix it. Right, I don't have exactly what yours says, but yours says vertical stretch or shrink, and then it says underneath it says y equals c times f of x, and then over to the right, it says c is greater than 1, and it says it stretches, okay? Behind that, if you write 0 is less than c is less than 1, that would shrink it vertically. So it would shrink it in this way. And the stretch of greater than 1 was stretching it up and down this way. Some of you have trouble with the word vertical and horizontal, so I'm trying to clarify. Then your sheet says horizontal stretch or shrink. That's already on your sheet, right? And it says this, y equals f of c times x. And then it says 0 is less than c is less than 1. And it says the word shrinks behind it. Okay, but if it's between 0 and 1 and you put it in here, it actually stretches horizontally out this way. And I would say by 1 over c, but you don't have to. You can say, if it's a 2 in there and you want to, no, it says between 0 and 1, I apologize. So if it said 1/2 x, I would say it's stretching by twice as far by the reciprocal. So let me just write that. If it said f of 1/2 x, stretches by 2. All right. And yours doesn't have anywhere where it tells you what it does the other direction. If c is greater than 1 for this one, then that is a horizontal compression or shrink by 1 over c. So if it said f of 3x, it would shrink by 1/3, and it would shrink in towards the y-axis. Just trying to make sure that you're not using this reference sheet with it wrong, okay? Because the reference sheet was wrong. I didn't ever read it that closely. I got it from a book and thought it was right, or got it from a teacher-made item, actually. Everybody okay? Tessa, you got what you want? Okay. The last one we need to talk about before we move to the other worksheet is the absolute value. Now, I'm not talking about just f of x equals absolute value of x, okay? I'm talking about when they give us some crazy function, like this is our f of x, and it looks like this. Okay? If you were to take and put an absolute value around the whole thing, it takes all the parts that used to be below here and flips them exactly how big they were up above there. So that would be the graph. It would have bump, 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 okay? On the other hand, if I take and put the absolute value in here, What that does, this is really weird, guys, is it totally erases all the negatives on the left, and it takes what was ever to the right and makes the graph have y-axis symmetry. All right, so on your notes, if you had a graph that was doing this, and you made it, if this was f of x, and you made it the absolute value of f of x, the new graph would look like this. Okay, all the y values are positive. It's changing y values. If it was inside like this, it cuts off the left of the parent function up here. I'm still using this one, okay? Would cut off the whole left side. So all that was left was this little tiny bump on the right over here. And then it makes it have y-axis symmetry, so it would take and do exactly that same little bump on this side. Thinking you didn't do those last year. Yes, no, no. All right, so this is an example that you have on your paper, and it wants you to describe what is the parent function of this. Remember we did parent functions yesterday? What's the easiest? Yeah, the parent is just the square root of x, which would go through 0, 0, 1, 1, 4, 2, looks like this, okay? Now we're supposed to decide what happened to it. Order of operations, can you describe to me what would happen? If we put a negative in here, what does that do? It reflects over which axis, though, when it's inside? Yes, across the y-axis. So it's reflected over the y-axis, so it's flipped this way, which would be over here. But then the second thing they did was a -1 on the back, which would shift it down. So it turned up. Down here is where they show it. Okay, yours was already done. That's what we're going to do on all of these. So what is the parent? I'm on the next page now if you're awake. What's the parent of this one? Okay, so f of x we're going to graph as the absolute value function. It is a V that goes through 2, 2, and 4, 4 because these are counting by twos. So it looks like this. What two things have happened? First, inside here they did this, which would be a, yes, a horizontal shift. Which way? Left 4. And then what is the second thing out here? That is a vertical stretch or shrink? Shrink. Or compression by 1/2. So if I take this and I shift it to the left 4, and then it's going up half as fast vertically. So when I went out here to 2, I went up 2, but now when I go 2 to the right, it only goes up 1. When I was going right 4, it was going up 4. Now when I go to the right 4, it only goes up half as much, so that would be 2. Remember, it's counting by twos. We'll do some on the calculator in a minute. Do you remember how to find that absolute value? There's an icky one we're going to want to check on the calculator in a minute. But the absolute value is under the math button, remember? And then you have to arrow to the right, and it'll say ABS, okay? Right, number 2, what's the parent function? F of x equals x squared. Give me some ordered pairs for that. 0, 0. At 2, when you squared it, would be up at 4. If you went out 3, it would be up at 9. We could just barely fit that on our graph paper. All right, what 2 things are happening to this graph according to the 4 and the 2? Okay, it is a vertical stretch up and down by 2, and the -4 on the back is a vertical shift down 4. So the whole thing is going to slide down 4 to there. You guys didn't check me. I messed up. The parent was supposed to be, the new one's going up by a stretch of 2, right? So I put in a 1, get out, go over 1, go up 2. The parent was supposed to be plain old x squared, so it should have gone through what? 1, 1, 2, 4. Is that what I did? Now I just erased it? 3, 9. Okay, just kidding. Okay, I did it right. I thought I messed it up. Okay, this one's going to go up twice as fast. So we're using this. If I put a 1 in there, what happens? Squared, I get 1, times 2 is 2, minus 4 is -2. If I go over 1, it's down here at -2. I think. If I go over 2, no, it should be at, okay, just kidding. I said if you put in a 1, you get out a -2. That's right. Okay. If you put in a 2, you square it, you get 4. What's 2 times 4 minus 4? 4. So at 2, it's all the way up here at 4. So this time it's going up faster. Okay, it's been stretched. I hate parabolas because you can't tell if it's changed vertically or horizontally. Again, you could have plotted, you could have done it with your calculator for that matter. Okay. What about this one? I love this one because I can handle this without messing it up, I think. They gave us the parent function. What are some points on square root of x? 1, 1. Next nice one, square root of 4 would be 2. Then if it went out 9, it would finally get up to 3. It doesn't go out that far. Only know that because I tried counting it 3 times. My blurry eyeballs. Everybody good? 1, 1, square root of 4 is 2, square root of 9 is 3. You good? What 2 things does this one do? In here is horizontal shift which way? Left 3. And then a vertical shift up or down? Don't look at my writing. Up 1. So basically, guys, every single one of the dots shifts left 3 and up 1. There's no stretching. Left 3, up 1. This dot here goes left 3, up 1. This dot that was over here goes left 3 and up 1. This dot that was way out here, 1, 2, 3, up 1. Okay, it should be exactly the same shape, shifted left 3 and up 1. Good? Then we get to the kind of trickier ones. This one isn't bad at all, really. Absolute value graph. Okay, if I do the parent in green, goes through what? What does it look like? What shape? It is a V. It goes through 1, 1, 2, 2, negative 1, 1, negative 2, positive 2. So it looks like this. Pretty good? Okay, two things are happening here. What two things? What does the 2 do first, though? Inside. So it is a horizontal compression. You could say by 2. I would say by 1/2. I'm not going to grade on that as long as you use the word horizontal compression or shrink. Okay, what about this symbol out here? What does that do? Okay. Then reflected over x-axis, which is up and down. Okay, so all of these points where it used to go over 1, up 1, it's going over 1/2 as far. Where it went over 2, up 2, it's only going over 1 before it's gone 2. And it's upside down, so it's doing this. And again, guess what? That's exactly the same graph. Okay? If you were to say, I'm going to reflect it and stretch it vertically, is the same as shrinking it horizontally. Because when you have a 2 in here with absolute values, it doesn't matter. Don't like that they give you these ones where it doesn't matter. But the words should say it was a horizontal shrink. All right. Number 5, the parent function is again just the absolute value. Whoops. So it goes through 0, 0, 2, 2, and 4, 4 because they gave us graph paper that counts by 2s. Okay. What things are happening? 3 things this time. The first thing, what does this do in here? Horizontal shift, which if you just said it shifted left 2, I would be fine. Now, because there isn't a reflection, I really don't care what order you tell me in, but this would kind of be next. That is a vertical stretch by 2. And then last is this guy on the back, which is the vertical shift down 3. And it actually doesn't matter if you stretch and shift down or shift down and then stretch. It's the reflection that messes with the order. Okay, so this corner point here that was the V vertex at 0, 0 is shifted left 2, which remember the graph paper, it's counting by 2s, and down 3, so it's here. Now, basically, instead of all of the boxes going up 1 and over 1 box, it's going to go up 2 when it goes over 1 because it's stretched up twice as fast. And we will do this one on the calculator. So you just can see some ordered pairs. So the calculator, oh, I kind of don't want to erase those. Okay, so I'm going to go down here and not use those. We were graphing absolute value of x, which is under math, arrow to the right, enter, and put an x in there. So that's going to be the green one. And then the second one was 2 absolute value of x. Help me out, guys, I forgot. -3. Did I shift mine? I don't remember going right. Did I? Hope I did. Left 2. I did shift it left 2? Okay. Anyway, here's the graph in a standard window. Is that what ours look like? I hope. Okay. If you do a zoom square, it'll look more like your graph paper. Is that what ours look like? Okay. We good? All right, number 6, I'm going to skip because we're going to do piecewise tomorrow. I'm going to number 7. What is a parent function here of f of x equals x cubed? It goes through 0, 0. What are some other points? 1, 1. What is 2 cubed? 2 cubed is 8. It's all the way up here. If you cube -1, you get -1, but if you cube -2, you get -8. That's the parent function. What 2 things have happened here? In here, what happened? Horizontal, shift, left, 1. So all the points would shift to the left 1. But then what is the absolute value on the whole thing doing? Yes, on the whole thing on the outside does not make the y-axis symmetry 1. It just makes everything positive. Reflects this bottom piece up. So we're going to shift everything to the right 1. And then the piece that used to go down here is now going up. It looks like a parabola. Okay, you don't have to have, basically it just makes everything above that. And I'm not going to ask you the words for what does the absolute value do, okay? I want to show you on the graphing calculator because they argued with me last period, so let's see. If I turn this on, go down and delete these. This is the basic cubic, okay? The second one I typed in is the one they wanted us to do, which mine's going to be the black one here when I turn it on. Okay? If we had put the absolute value inside on only the x, anybody think they know what that's going to look like? Do you remember what putting it inside does? It makes it have symmetry to what? The y-axis, okay? What that would have done would have been to shift and then cut off the left and make it, we'd shifted left 1 still, coincides here, but then it would have cut off everything to the left and made it y-axis symmetric. So it would be like almost a skinny parabola up 1. All right. Where am I at? So your assignment, do I still have 3 minutes, guys? Yes? Okay. Your assignment is to do these problems on page 52. Okay, it's on the board, it's on your homework check sheet. You should do these on graph paper and make them nice and accurate. So there's graph paper laying in the back. On your way out, grab a couple sheets of graph paper. Now, before we give up and pack up, I'd like to introduce this idea. We can finish these tomorrow if we need to. If this is the parent function over here, this is on the back of your worksheet. If this is the parent over here on my slides, what happened to this one? From here to here. It went down, right? Shifted down. Can you see that it went down? Which one of these would shift something down? Yes. F of x minus 5 would shift it down 5. What happened here? From this graph, that's the parent, to this one. It is reflected over x, which would actually look like this, okay? But then it's also shifted up, which is this one. Can you tell what happened here? What happened? How did it go off the bottom? Yes, it is a vertical stretch. See this little teeny bump right here now goes all the way up here. Which of these is a vertical stretch? Anybody tell me which of those is a vertical stretch? D, yes. These questions are on the quiz. Okay, everything that was negative became positive. What's that? It is absolute value on the outside. All right, we'll start with these tomorrow. As a warm-up, we'll go back over these. Take graph paper on your way out.